All right, just got one email requesting that I go through and discuss how to do complicated RS structure. There we go. So we've got the tetrahydrocannabinol, and you can actually identify the chiral centers. So to identify the chiral centers, what we're looking for are carbons that are, we're always focusing on carbons. We're not going to worry about chiral nitrogens and oxygens and phosphoruses. They do exist. We're not going to worry with them. But we're looking for carbon, specifically carbon that is sp3 hybridized and has 4 bonds. So we're eliminating anything that has double bonds or triple bonds associated with it. So we go through these molecules, that and that are automatically gone. So that's gone. All of these carbons are gone. That oxygen's gone. And now we need to start tweezing out the carbons that remain. Which ones are chiral? This is 2-methyl group, so it's not chiral. CH2s aren't chiral. CH3s aren't chiral. So we got this big nasty molecule, and basically it just boils down to 2 chiral centers. That's it. So we've got this one and this one. Let's see if I got a different color pen. Yes, I do. Actually, let's work with blue. Blue's a little bit easier to work with. So we got this carbon and this carbon, both of which are chiral. So first thing we need to do next is we need to establish the priorities. So we've got a hydrogen. So we'll start with this one. We've got, for this carbon, we've got a hydrogen coming off. Hydrogen has the lowest priority. We've got 1 carbon up and to the right, 1 carbon up and to the left, and a carbon down. So with these 3 carbons, we need to establish a priority. So in order to do that, we've got to look at what's bound to those carbons. We've got a carbon, carbon, hydrogen, carbon, hydrogen, hydrogen, carbon, 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 carbon. So that's where this shorthand comes from when I write it over here. We have a C, C, H, H. We have a C, 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 C. And we have a C, 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 H. So pretty easy, the one with more carbons, because what we're looking for is the first point of difference. All 3 are bound to another carbon. This one's bound to a hydrogen, so this makes it the 3rd priority. This one's bound to 2 carbons, makes it the 2nd priority. This is bound to 1 carbon, this makes it the highest priority. So now that we have the priorities established, now we can start determining what the chirality is. Now, a structure like this would be incredibly hard to build, especially on exam, so there's a few shortcuts we can use to figure this out. One, if you're comfortable with doing the drawings, if the hydrogen here is a wedge, instead of doing the clockwise as R, counterclockwise as S, you just reverse it. Clockwise is S, counterclockwise is R. So we have it going 1, 2, 3. This would be S if the hydrogen was wedge, was dashed. Since it goes counterclockwise in its wedge, this ends up being the R conformation. But let's say you don't feel comfortable with doing that. How would you do this with the modeling kit? So with the modeling kit, where are you? Oh, you're fine. You don't have to build the full molecule. What you can do is you can color code your atoms. So I've got a carbon, and I'm going to number them. So I'm going to have hydrogen here is the white, lowest priority. I'll have my highest priority one is blue, and then we'll do purple and yellow. So what I can do is, instead of having to build the full molecules, I'll just take my modeling kit. And I'll just kind of use these as substitutes. So I've got my yellow, purple, and blue with white coming on the page. And now I can turn it. And what I see is that I've got blue, purple, yellow. This is clockwise rotation from your point of view. So it's R. So this chiral center here is the R chiral center. We can repeat this process for the other carbon. So if I go to this carbon, blow it up, I've got carbon, hydrogen, carbon, carbon, and carbon. So hydrogen here is going to be the lowest priority 4. I guess just pop out the chat so this way I can actually see if anyone's trying to write me. And then now I need to look at what's bound to these carbons. So this one has a carbon, hydrogen, hydrogen. This one has a carbon, 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 hydrogen. This carbon here is actually double bound to another carbon. It's surrounded by carbon, so actually in this case we count, when we do the CIP rules, we don't count this as just being bound to 2, we actually count as always being bound to 3. The third one is going to be the second bond. So this is a carbon, 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 carbon. This one is a carbon, hydrogen, hydrogen. This one is a carbon, carbon, hydrogen. So since this is bound to more carbons, this is it being top priority, second, and third priority. So again, going from the figures, since the hydrogen here is dashed, we can actually just read it as is. So 1, 2, 3, this is clockwise, so this is the R conformation. Now again, we could also build it. So we've got white as the highest, as the lowest priority. Blue is the second highest priority. Purple is the third highest, is the second highest priority, and then the third one being yellow. And when I build that, again, I'm going to get this R conformation. So when it comes to identifying the RS chirality, especially if you got like a big nasty molecule, break it into smaller parts. It is good that you try to build the whole molecule, just because if you have to do multiple chiral centers, it kind of saves you a little bit of time because you can just move from part to part of the molecule. But especially if you're doing something as big as THC, this is really hard to work with, but break it into little problems. I can give you all types of nightmare monster molecules, but at the end of the day, identifying their RS chirality really is just a matter of looking locally and just working your way out. Now, again, when we start doing alkanes, we're actually going to find alkanes are the hardest for RS, because in this molecule we had oxygens, we had functional groups, we had alkenes. If we're working with alkanes, it's all CH bonds, and what we're looking for is the first branch to terminate or the first branch to branch, and that's going to set our priorities. But something like this monstrosity, it's still not that bad to work with. We just have to break it in little parts. So again, identifying the chiral centers. We're looking for carbons that don't have any double bonds. We're just looking for things that have 4 bonds. So this, and this are all chiral. Now we start looking at what's bound to them. So we do this first one. We've got a carbon bound to an OH, bound to a carbon, bound to a carbon, bound to a hydrogen. Hydrogen here is going to be lowest priority, 4. Oxygen is going to be the highest priority, 1. This carbon is bound to a carbon and 2 hydrogens. This carbon is bound to 2 hydrogens. And then as we start working our way out, ooh, this is actually a good one. So if we look at the next carbon, this carbon is bound to an oxygen, a carbon, and a carbon. This one is bound to a bromine, hydrogen, and a carbon. So the first point of difference here is going to be the oxygen and the bromine. This actually makes this direction the higher priority because it's the first one to encounter the heavier heteroatom, the one that isn't a carbon or a hydrogen. So this ends up being top priority, second priority, so, or relative to each other, 2 and 3. Now, since our hydrogen is wedged, if we look at it, it goes 1, 2, 3. That's counterclockwise, but because the H is coming out at us, it's going to be reversed. It's going to be actually, this is going to end up being an R center. Or you can build it and say that this color is the highest, second, third, lowest, and just turn your molecule so that you can see it. You don't need to build a full molecule. You can definitely color code. So I'd say that's the R conformation. When we go down to the bromine now here. Bromine's highest, hydrogen's lowest. This carbon branches first, and on top of that it's got the bromine, so it's the second highest, third highest. Because the hydrogen's in the back, we can read it as is, so 1, 2, 3 counterclockwise. This is an S center. For this bromine, bromine's the highest priority. The hydrogen coming out is lowest. This carbon, oh, actually no, there is no hydrogen. Sorry. So we have 3 carbons. This carbon is bound to another carbon, 2 hydrogens. This one's bound to a bromine, a carbon, and a hydrogen. This one's bound to an oxygen, 2 carbons. So first point of difference, the bromine is higher, followed by the oxygen, followed by the carbon. So it looks like 1, 2, 3. This is actually a good one. So this would be one I would color code, but definitely if we treated this one like it was a hydrogen and it is the lowest priority, it would be a wedge, so it would be reversed. So 1, 2, 3 is clockwise. Counterclockwise would make this S. So it's not that you should, it's not that CH2s are being ignored, it's just that you have to look at what's beyond it. So it's not just what's the same around it, it's what's same depending on which direction you go. So if we look at a much more simple molecule, so this molecule has 2 chiral centers. Even though these are both CH2 groups, this is still chiral because we have to look left and right. So if we look left, we see a CH2, 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 CH with a CH3 and CH2, and we're back to where we started. If we go the other way, CH2, a branch, CH2, CH2, CH2. So from the perspective of that carbon, we've got an OH, an H, and then CH2, CCH3, H, CH2, and so forth. If we go the other way, we see a CH2, CH2, CH2. Like, you can definitely look left and right and see that they're not the same thing. So again, it's not the local environment, it's the whole thing once you get around. Now, if we do something like this, this ends up not being chiral because even though we got the stereochemistry there, it's nothing but CH2s left, nothing but CH2 rights. And if we do two wedge CO3s, this ends up not being chiral because they look the same. This would actually be a meso structure. But if we flip the wedges and the dashes, so we have one wedge and one dash, this would end up being chiral again because when you go left, it sees a wedge CH3. When you go right, it sees a dash CH3. So any questions out there? That was the only one I've received this morning, was going over bigger, nastier structures for RS chirality. Sorry, responding to a message off to the side. It is hard, but that's also, so when it comes out, we're setting up the organic, we're trying to get the hardest stuff out of the way first. So we're getting the NMR, we're getting the mass spec, we're getting the RS, and we're getting the Newman Fisher projections. We're trying to get that foundation laid now. And then particularly as you start seeing it with alkanes, oh, Squeaky's doing fine right now. She's curled up on her blanket. But yeah, the RS we're trying to get out because as you'll see in the test tube packets, you get questions like this. And you're named to ask this, and you need to know the RS configuration. So the naming isn't hard. 1, 2, 3, 4, 5, 6. This is a hexane, and it's a 3-methyl. And then you have to figure out the RS. So all the hydrogen goes back, and first to terminate is this one. So it's 3, 2, 1. So 1, 2, 3. This is R, 3-methyl hexane. But once you now do the RS, identifying these RS chiral centers gets pretty straightforward. Well, what other questions you got for me today? And if you don't believe me, you can ask your peers who like have had organic before and ask them about those test 2 packets that they've just looked at. They're going to tell you this material is actually a lot easier. You're still going to see a lot of the NMR on there. You're still going to see the mass spec on there. But as far as like the new material is a lot easier to learn. Yeah, so with this course, if you get an absolute 0 on any exam, it takes you down 12 points over on the course. So start with 100. If you get an absolute 0, now you're down to an 88 in the course. And that assumes you did absolutely like none of the multiple choice right, none of the free first response. Basically, you like turned in a blank exam. But if you get A's on everything else, you're probably looking still practically at a C in the course because you're not going to get 100% on every exam. But again, failing the course, like outright failing it, you're talking about failing 2 and then probably 3 exams. At that point, I think it's pretty reasonable to say that you're not understanding the material. But as far as like getting like a 60 on the first exam, you can definitely come back with a B or C in the course just fine. Getting an A in the course is going to be a lot harder. So if you take that, for easy numbers, we'll say a 50 on the first exam, you've lost 6 points in the class. That stitched you down to a 94. That's a lot of things having to go in your favor to kind of keep those last 4.5 points. But it can be done. So the course here is not meant to like throw you out for one bad exam. It's more when you start seeing like 2 and 3 exams and 2 or 3 exams, like at that point it's time to kind of like bail out. And a lot of it is, especially if you're getting to exam 3 and you're still not doing well, there's a foundation that's just not there because test 4 and the final exam are all kind of building on each other. So test 4 is going to be the alkenes. Well, the alkenes are just reverse of alcohol reactions for the most part. There's definitely exceptions, but for the most part, it's reversing alcohol reactions. Well, test 3 is alcohol reactions. So if you couldn't do it the Ford way, you're not going to be able to do it the reverse way, and you're kind of like not set up for success with the alkene. And the alkenes are going to borrow heavily from the naming of the alcohols. They take very similar priority rules, very similar approaches. So if you can't name an alcohol, you know, you're not going to really do well on alkenes because you sort of don't understand how to name a functional group like that. So again, like failing the first exam does not preclude you from passing the class. You just made it very hard to get an A in the course, but definitely a B and C are very doable. Then I've had plenty of students do it. And as I've stated, previous students will tell you the first exam is definitely the hardest exam. It is the most theoretical, it is the most abstract in terms of new material. A lot of it's going to get a lot more concrete and a lot of it's going to build on itself. So if you do well on test 2, test 3 is probably not going to be that bad. And then if you're doing well on test 3, test 4 is going to be even easier. And then the final exam, hit or miss, it is a final exam. But generally speaking, the questions in the final exam should be pretty reasonable compared to everything else you've done in the class. And I think state has the policy if you fail the first exam, you're automatically withdrawn from the course. We don't do that. That's a really draconian approach to teaching. other questions out there? All right, so not seeing any concurrent viewers, so I got the chat up if you got questions. Otherwise, I'm going to send some emails and get a little bit of work done. Again, these are office hours. These are not lectures or lessons. So if you got a question, type it up. Keep in mind there's about a 45-second, looks like closer to 60-second lag this morning. So when you post it, it does take me a minute to get to it, but I will respond. All right, so that's kind of it for the live stream. So if you do ever have questions, please feel free to email them in advance. Otherwise, I will see you all tomorrow.